Hello, my name is Richard Bosley, and I'm in the Microsoft US Education Organization here at Microsoft. And today we're going to talk about configuring Windows 10 devices to wake and update outside of class time. Now, in education, there are three main issues that we see in regards to shared devices. The first issue is slow logons. It's a common complaint that logons for Windows 7 or maybe even Windows 10 devices are taking about 2 to 5 minutes. Teachers and students are generally frustrated by the amount of time it takes for a student to get up and running once class starts. Usually this takes up a good portion of class time. Teachers spend troubleshooting technology rather than using the technology to teach in the classroom. What we're finding is that stale GPOs can usually be the main culprit, and these GPOs could have been around since Windows 2000 or even Windows XP. Now is a good time to clean those up if you're making your migration over to Windows 10. And if you want to troubleshooting is relatively easy. Take a machine and isolate it into its own organizational unit. And then on that OU, block any inheritance from any additional group policies. And by doing this, you can rule out any group policies and see if the performance increases or improves during the logon of the device. However, with Windows 10, the provisioning of applications on the first logon contributes to long logon times as well, especially if you have older hardware. This is generally, again, on the first logon. Subsequent logons shouldn't take too long for students to get onto the device. The second issue that we hear about is around too many profiles that use up too much disk space. And customers often resort to using their own custom scripts or some other complex method to clean up the profiles on the device to reduce the amount of disk space that they use. And this is one of the main reasons that customers reimage every summer, because these devices have dozens, if not hundreds, of profiles, and it's easier just to wipe and load the device than it is to try to clean up any of those profiles. Then the third issue that we commonly see is updates installing during class time, and that's the premise of this presentation today. We often resort to reimaging at the end of the year because these devices are not in compliance. They're not up to date, and they need to be up to date. And it's just easier to wipe and load the device because of issue number 2 plus issue number 3, where they aren't updated at all during the school year. However, as we know, this is not a security best practice. The best practice would be to apply updates during the school year as they come out, so these devices are secure throughout the entire year and not just secure when they're delivered for the first time. Now, with Windows 10, we've introduced this new concept called modern management, and modern management leverages this new Windows 10 built-in MDM agent. So if you're used to Configuration Manager or any third-party management tool that's out there, you're well aware of the need for deploying a agent to the device in order to get that device managed. Well, with Windows 10, that's not necessary anymore. With Windows 10, we can leverage the built-in MDM agent that can communicate out to any MDM server and be managed from that MDM. Now, with Windows 10, new features that are designed with MDM in mind first, and sometimes we'll see a group policy, other times we won't. MDM policies can be managed via Microsoft Intune and other third-party MDM providers. We can also manage these through provisioning packages or scripts leveraging WMI. And MDM policies are referred to as configuration service providers or CSPs. And more details can be found at aka.ms/MDM10. That has a list of all of the configuration service providers that is in Windows. In Windows 10 1607, we introduced a new CSP called Shared PC. And Shared PC addresses the three main issues that I mentioned earlier. We improve logon times by configuring a number of local policies on the device. We also deal with account management by removing stale profiles by default in Windows 10 1703 if they're inactive for more than 30 days. But in 1607, when we first introduced Shared PC, we started to delete the profiles based on free disk space thresholds. So if the device fell below 25% free disk, we will delete the oldest profiles first until 50% free disk space is reached. And this assumes that the profiles are using all the disk space. If content is in ctemp or some other folder, we won't be deleting that content, we will only be deleting profiles. And we've also added the ability for temporary users to log on to a device. So if you have configured account management within Shared PC to allow temporary users can sign in without an account, and they'll have a guest account button that's on the logon screen. So they click that button, they'll be on the device. When they log off, their profile will be removed. And then updates can install outside of class time. So power management can be configured to allow the device to wake outside of class time, and by default, we use 12 a.m., but this can be configured. And active hours was introduced in Windows 10 16.07 that prevents updates from installing during class time. And more information can be found at this link below. So Shared PC, as I mentioned earlier, sets local policies. And these allow for quicker logons. It also allows for preventing the changing of the lock screen. Changing the power button, we change the power button so that the power button and lid close functions are both set to sleep. So if a student were to hit the power button to think that they're shutting the device down, it actually just sleeps the device instead of doing a full power down. We also modify the sleep settings to preserve more battery life and to allow better wake experience during the maintenance period. We also disable Microsoft Consumer Experiences. So by disabling these consumer experiences, students will not be prompted for suggested applications and other things that can be distracting to an education environment. We also prevent the usage of OneDrive for file storage. What this means is that the student will not be able to sync content directly to OneDrive using File Explorer. However, they can use the OneDrive Universal Windows Platform app that can be downloaded from the Windows Store. Now, this policy can be disabled either through group policy or through MDM, so that students will be able to use OneDrive File Sync directly through File Explorer. We also disable the use of biometrics. So using the Windows Hello Camera, if you have a Windows Hello Camera capable device, we won't be able to do that through Shared PC. We also do not allow for fingerprint readers or any other biometric, which could be iris or any of those, due to the fact that shared devices we actually only store 10 biometric inputs. So if you have shared devices that could have more than 10 students, we will not store those biometrics. On top of this, in a shared environment, if a student is logging on to multiple devices, they will have to set their biometrics up every single time. We do not store the biometrics centrally, whether that be an on-prem environment or through the cloud. So because those biometrics are only stored local on the device, it makes it challenging to leverage biometrics within a shared device scenario. And we also configure the automatic maintenance settings in Windows 10. So this is what we use to wake the device up at, like I mentioned earlier, the default time of 12 a.m. So guest accounts. Guest accounts are temporary local accounts that do not require any credentials. And a guest button, like I mentioned earlier, is shown on the logon screen that a user can select. And that guest account is deleted when the user signs out of the device. This is a good option for students that have a hard time typing credentials, or those that might be of younger grade levels that you may have already been creating single character usernames and passwords through your domain controller. This way they can just leverage the guest account, and yes, it will have to create a new profile every time, which can be time consuming. However, this is another option that you have with Shared PC. With account management, when that is enabled, accounts are automatically deleted. And the account deletion applies to not only your on-premises Active Directory accounts, but also Azure Active Directory and local accounts that are created either by guest or the kiosk options through Shared PC. Deletion is performed at sign-off and at system maintenance. And by default, this is 12 a.m. Configurable to delete accounts immediately at sign-out or when the disk space is low. And I mentioned those thresholds earlier in a previous slide. In 1703, we enabled the inactive option to delete inactive accounts after 30 days. Now, with power management, Shared PC will take advantage of the default Windows 10 maintenance period at 12 a.m., and it's highly recommended to keep these devices in sleep mode. If you use the Set Power Policies option in Shared PC to take advantage of the recommended power settings, we will customize the power button and the close lid functions to both sleep. But this will also set the power policies to allow the device to wake during the maintenance period. And then on older devices that don't have ACPI wake alarms, shared PC will override the real-time clock to allow for the device to wake from sleep. We do this through a powerconfig command. Now this ensures that old and new devices can wake up more reliably to perform maintenance. And shared PC does not configure Windows Update. However, it is recommended to set Windows Update to allow updates to install during automatic maintenance. And lastly, devices in connected standby mode do not wake from RTC wake alarms. This is important to understand because you may have Surface devices or tablets that could be leveraging connected standby. These devices, in order for them to wake using an RTC wake alarm, they need to be in the S3 sleep state for RTC wake to work. We're aware of this issue, and we're looking at possibly solving this for connected standby devices, but for now, devices will need to be in S3. So you may want to check your devices, and you can do that using powerconfig/A and from a command prompt. And if you run that, it'll tell you the sleep states that your device supports. So in order to configure the Windows Update settings that I was mentioning in the previous slide, we can do that through a number of different ways. The first way is through group policy. And if we do that through group policy, we need to go to configure automatic updates under the Windows Updates node in group policy and select enabled. And then we'll want to select the option 4, which is auto download and schedule the install, and then check the box that says install during automatic maintenance. When we do that, the device will then install during the automatic maintenance period, which by default is midnight. And then there's a 2-hour randomization that we also set through shared PC, so the device may not actually show up as waking up at 12 a.m., but it could be sometime between 12 and 2 a.m. Now through Intune or Intune for Education, if we're using Intune for Education, we can set this up during the express configuration of a group. So in the screenshot you see here, I have a group called Students of Contoso High School, and we are setting the auto install and reboot at maintenance time option for Windows Update. Through full Intune, we have the same capability where we can specify the automatic update behavior to auto install and restart at maintenance time. All of these settings are the exact same that we saw through group policy of automatic updates being set to 4. And then lastly, through a provisioning package through Windows Configuration Designer, we can set allow auto update to auto install and restart without end user control. Again, all of these options are the same. Now, if you're running 1607 today, or if you looked at this in 1607, there were some issues. 1607, shared PC was only applicable via MDM or provisioning package. However, not many customers used MDM to manage Windows 10 at the time, and Intune, quite frankly, had some pretty significant gaps in an education environment. We addressed this in Intune for Education when the Creators Update came out back in March. However, many customers today still have SCCM, or if they don't have SCCM, they're using group policy or some third-party management tool. However, SCCM couldn't apply the provisioning packages because they need to be silently installed. In order to do that, you needed to have the package signed with a certificate. And third-party tools, like I mentioned earlier, were affected by this same problem. So in the Creators Update in 1703, we addressed these concerns with provisioning packages being able to apply silently through PowerShell. And shared PC is now exposed through WMI. So this means you can script this if you want to. And we also have included Intune and Intune for Education UI so that you can apply these policies to your devices. Which means now, regardless of how you manage your devices, Windows 10 1703 or greater will be able to manage the shared PC CSP. So in order to apply this with PowerShell, we need to create a provisioning package first, and if you've never done that before, you can go to the Windows Store and download Windows Configuration Designer. When you go through that process, it's going to ask you how you want to create your package. Do you want to create a package for a desktop device, if you want to do it for a Surface Hub, for a kiosk? And there's also an option for advanced configuration. I'm going to demo this in a minute to show exactly what this process looks like. However, regardless of how you create the package, in the end, you will end up with a PPKG file that you export after the package has been completed. Once you have that PPKG file, you can then apply it through PowerShell using the install provisioning package commandlet, using the commandlet syntax that you see on the screen. So how do we apply this with Intune for Education? Well, I showed earlier that we can do that through the express configuration settings, but if you already have groups that are configured, but you did not select shared PC, then we have options here through the group settings. So if you go into your groups, select a group, and then go to the settings option at the top, you will then see device sharing. So expand device sharing and then select optimize devices for shared use. And in full Intune, we can do the same thing. However, what you may have noticed in the previous slide is the picture only allows you to turn on shared PC, but there are some other granular settings that you may want to configure. In this example here, I have a setting that says enable local storage. So by default with shared PC, we restrict local storage so users can't access the file explorer and access other folders outside of their own downloads folder within their profile. So if you want to enable local storage, but you're using Intune for Education and you've turned on shared PC, you would have to go in and create a custom OMA URI to set the local storage option. So here what we're seeing is I have a custom OMA URI that is looking at the vendor MSFT shared PC restrict local storage policy, and we are setting that policy to a Boolean value of false. And how do we apply shared PC with GPO? Well, with GPO, there are a couple of options. You can create a group policy to create a startup or shutdown script. However, most devices are asleep, so these devices may never actually shut down or start up. Therefore, they would never apply your provisioning package that you might have a PowerShell script that is running the install provisioning package commandlet. Therefore, you need another option, and that option would be creating a scheduled task within group policy. So in group policy, you can create a group policy preference and apply a provisioning package. So in the steps that we have listed here, we need to obviously create a provisioning package, then we need to copy that to some network location. Once we've done that, we need to create a group policy preference to copy the provisioning package to a local location on the device, as well as create a scheduled task in that same preference to execute that provisioning package. So it's a two-step process. So in this example screenshot that you see here, I have a provisioning package that I've created, and that provisioning package is being referenced by this scheduled task, and this scheduled task is executing PowerShell. And then on the next slide here, we will see that the scheduled task action settings are set to start program, and we reference the PowerShell exe, and then we add a number of arguments to then execute install-provisioning package, and I pass the local path of the provisioning package that's on my device. Okay, in the next step, we will go over the demo of how we create our provisioning package and how we apply that same provisioning package through PowerShell. So what we see here is Windows Configuration Designer, and this has already been installed from the Windows Store. Now, if you don't have this installed already, go to the Windows Store, do a search for Windows Configuration Designer, and then install it. So in Windows Configuration Designer, we have the ability to create different provisioning package types. So on the left-hand side, we see that I have the ability to create a desktop device provisioning package. I can also create a kiosk one for mobile devices, and one for Surface Hubs. But I also have an option here that says Advanced Provisioning. Now, when you have brand new devices that are coming from your reseller or OEM, those devices are going to generally be shipped with some version of Windows. They could come with 1607, or they could be shipping with 1703. Most should be shipping with 1703 now if they aren't already. So with those devices, you'll be able to use the provisioning package to bootstrap that device and have it consume the provisioning package that you create here. So for those desktop devices that are brand new, you would most likely want to go through the Provision Desktop Devices wizard. So if we quickly go through this, we will see a wizard come up here, and it's going to prompt us for some additional information. So in this case, we have device name, we have a product key we can specify, and then we have the configure devices for shared use option. This is the shared PC option that we've been talking about throughout this presentation. So if I have my brand new devices and I want to leverage Configuration Designer to set those devices up, instead of using SCCM or some other management tool that I've been using for a while now, I can type in a prefix for my organization. So in this case, it could be my edu. And then I have the capability here of specifying a serial number or random characters, just depends on which you want to select. I can then enter my product key. So if I have Windows 10 Education rights, I can put my Windows 10 Education key here, or I could put Windows 10 Enterprise. Either of those would work. Assuming that I'm upgrading from a Windows 10 Pro device, I can do Windows 10 Enterprise or Education. If I have Windows 10 Home device, a home device can only go to Windows 10 Education, or it can go to Windows 10 Pro. It cannot go to Windows 10 Enterprise. And then lastly, I have an option here to remove any pre-installed software that the OEM may have installed. What this will do is a PC reset, and this reset will take 20 to 30 minutes. Now, I can continue to go along through the rest of this wizard. So here I have my wireless SSID. Now, keep in mind here that we only support WPA2 networks with pre-shared keys. So in this case, I'm going to type in my network, and then whatever the password is for that network. If I'm testing this, or if I've got physical hardware, so if I was testing this in a VM, I wouldn't want to put my Wi-Fi network here. I would uncheck this option, and then this would just use an Ethernet connection. Now I also have the ability to designate how I want to enroll my device. Do I want to enroll it into AD, or do I want to do it in Azure AD? Or do I want to just create a local admin account? So what I can do here is I can enroll it into Azure AD if I am using Azure Active Directory and I want to manage through Microsoft Intune. So here I can generate my bulk token, and the bulk token will allow me to enroll with this provisioning package multiple devices. So in this case, I'll get my bulk enrollment token. And then optionally, I can create a local administrator account as well. Now I also have the ability through my provisioning package to add additional applications. So if I have an application that is an MSI type, I can specify that. Also, if I have an application that's an executable type, I can also specify that. However, if you're doing MSIs, we pre-fill in the MSI exec command in order to install the application silently. I can also add any additional certificates, and then now I'm ready to create my package. However, we actually aren't ready because we want to configure shared PC. So earlier, we checked the option to configure devices for shared use. However, there's some additional settings that you may want to configure. So if we go into the advanced editor, we'll see on the right-hand side over here, we have a number of things that have already been set. So for shared PC, we have some shared PC options here. Now in shared PC, by default, we automatically specify the domain join and guest for what kind of accounts that we want to leverage. Now we also have the deletion policy, or how we delete the accounts that are using up our disk space. So by default, we will delete at the disk space threshold. However, there are some additional options through here that you may want to select. For instance, delete at disk space threshold and inactive threshold. So if you have inactive profiles that haven't been used in 30 days, then you can specify here that you want to delete not only just at the disk space thresholds that we mentioned earlier in the presentation, but that you also want to delete at the inactive threshold. Now, from a disk level caching and disk level deletion perspective, these numbers are the threshold numbers that we were talking about earlier. So disk space threshold for account caching. We will stop deleting accounts when available disk space reaches this threshold. Now, there's a UI bug here that shows that at 25, this actually should be 50, because this is 50% free disk space. Now, for disk level deletion, this value by default is 25, and you can leave, you don't have to set this, but just to keep things consistent here, I'm setting it manually to 25. So what this means is that if free disk space falls below 25%, we will delete up to 50% of free disk space, providing that profiles are what are responsible for the bloat of the disk space usage. Now we also have account manager set to true, so we want to enable this in order for this to clean up the profiles. And then we have our inactive threshold. So I mentioned earlier that we can configure this option, and this is a good option to configure if you have students that might leave for the summer and then they come back in the fall and it's been 90 days or around 90 days between the last time they've logged onto the device and when they've come back to school. So in this case, you may want to actually increase this to 90, could be 180. That all really depends on whether you have students that are in this kind of scenario. In general, most shared environments, 30 days is probably good. You may want to expand that maybe to 60 days to take into account maybe winter break. I'm not sure if winter break is 30 days for you, but if it is, then that might be a little too short to have that at 30. You may want that to be 60. So this number is going to depend a lot on your environment and how your students log on to these devices. Now, as it pertains to policy customization, I mentioned earlier around the power policy settings and when we wake the devices up. So by default, we use automatic maintenance in Windows 10, and automatic maintenance is set to 0 by default, which is midnight. And this setting here is actually given as an offset from midnight. So when you customize this setting, you're not setting it as 0, 1, 2, 3, although you could, but if you wanted to set this, for instance, to something like to 12 noon, then you'll need to do the calculation of what that time is. Or if you wanted to do it at 2 a.m., then you have to put 120 in here instead of 2. So just understand that this is an offset of midnight as opposed to 0, 1, 2, so on and so forth. We can also customize the max page file size if necessary. And then restricting local storage, and this is an important one to understand. So restricting local storage means that you don't have access to the files to File Explorer. The only thing you have access to within File Explorer is the Downloads folder. You don't have access to your other folders within File Explorer. So you wouldn't be able to see C Windows, you wouldn't be able to see C Program Files or any of those others. You would only be able to see your C user and then your user ID and slash downloads. So in this case, what you may find is that when you test this out and you have shared PC configured, you have it set to not configured, what you may find is that you still have no access to the other folders within the file system through File Explorer. That's because not configured and true are the same setting. So if you want to test this out and you want to still have access to the file system through File Explorer and all the folders, so you can get access to logs or whatever else that you need to get access to, you'll want to set this to false. And if you have your students signing into the device and they need to access other pieces of the file system outside of their C downloads folder, then you'll also need to set this to false. If you don't have those requirements and you only want your students to allow access or have access to their own personal downloads folder, then set this value to true or keep it at not configured. Now, set EDU policies. Set EDU policies configures the device so that it is only it is configured for an education environment. And these appropriate policies would be policies such as the ability for consumer experiences to be disabled, so they don't get suggested applications on the start menu and a number of other things. And then our power policy settings, these power policy settings are configured so the users cannot change power settings, and they also cannot override the power state transitions to sleep. So for instance, when they close the lid of the device or if they hit the power button, all of those power state transitions will go to sleep as opposed to turning off the device. And then we also turn off hibernate. We have sign in on resume, and then we also have sleep timeout. And this sleep timeout option, this is actually in minutes. So by default, this is 5 minutes. Where you see here, the default value here is 300. This should be set to, in my opinion, 3600 because this is going to be 1 hour. This is important because this is going to give your device, when you do wake it up, it's going to give the device enough time to be on so that it can get any policies it might need from SCCM in order to install any updates that are required for the device. So you may want to customize this setting. So by customizing all of these settings for shared PC, we're now ready in this state for the device to be able to wake up and apply any updates that are necessary. So now we're ready to export this package and apply it to a device. So at the top here, we have an option that says Export Provisioning Package. So when we click on that, we'll have some options here to build and just keep these at default. We don't need to encrypt or sign the package. Just click Next. And then we'll click Next again, and then Build. So now our package has been built, and it's in our user profile under Documents, Windows Imaging, and Configuration Designer. And when we click on that, we get to the project that we created, and in this folder we'll see a file called project_32.ppkg. Yours is obviously going to be named something different, but it's the ppkg file that we want because this is what we are going to apply to our device. So I've copied this provisioning package and now I'm going to apply it to this virtual machine. So let's go ahead and copy it somewhere locally. And then now I want to use PowerShell to execute this provisioning package. So I'm going to open up a admin command prompt here. So I'm using the install provisioning package commandlet. It is now applied, and then it is going to restart the device. And this is how the process would be if you were to manually do this through PowerShell. However, you will most likely want to do this through something like System Center Configuration Manager or using something like Group Policy or another third-party management tool. But the command is the exact same. Doesn't matter what tool you're running, you can execute that command and do the installation of the provisioning package. Okay, so the device is rebooting. And now we see that we have the guest button on the logon screen, and it's asking us for our other user credentials. So I'll log on to the device with my my Azure Active Directory credential, and now I'm in the device. And if we go under Accounts and Access Worker School, under the Azure Active Directory tenant that we're connected to, we can click on Info, and then we'll be able to see the sync status of the device. And at this point, Shared PC is now applied. So if I go and look at, if I go to Task Scheduler, it's just one easy way of validating this. And I go under Shared PC, I'll see here that the task status is ready. And if this is not configured for Shared PC, then this would be disabled. Now you can also grab your management logs if you wanted to validate. So if we go back into settings, and go into accounts, if you're running 1709 at least, this is easier to check. If you're running 1703 or 1607, the management logs are a little bit more challenging to read because they're just straight XML. But if we create a report here, and then click this export button under the C users public documents MDM diagnostics folder, we'll see our report. So this report is it's an HTML file. Double click that. This will then tell us the MDM diagnostic information about the device. And in here, we can do a search for shared PC, and we see that we have a number of shared PC settings that have been applied to the device. If we keep searching through here, scroll bar. So we can see that these policies for shared PC were actually applied through provisioning, as opposed to something that could be applied through MDM with Azure Active Directory, which we have some policies that have been applied via that route. Now, because this is a virtual machine, we won't be able to actually set a RTC wake timer to validate that this device is going to wake up. But if you wanted to test this out on a physical machine, you can type in powercfg/wake timers, and this will tell you any wake timers that are scheduled to wake the device. With shared PC turned on, you should see a wake timer configured. Alternatively, if you wanted to validate if your device does support S3 sleep instead of connected standby, you can type in powerconfig/A, and then that will tell you the different sleep states the device supports. Again, in this case, because it's a VM, I don't support any sleep states, therefore I can't actually wake the device. Now, if you wanted to do something like this through group policy, like I mentioned earlier, we would need to copy our provisioning package to a local folder on the device, and then we need to execute that provisioning package somehow. And again, there are some restrictions if you wanted to do this through startup scripts or shutdown scripts, so I feel the best way to do this is to copy the file locally, execute through scheduled task. So in order to do this, we need to create a group policy preference. So in this case, I have a preference that has already been created, and I've got two items in this preference. I have a files preference, and then I also have a scheduled tasks preference. So under files, we need to copy our provisioning package somewhere. So what I've done is I've already created this, and I have the file located in my sysvol folder. So I've got my domain, sysvol, and under bluelabs.azure, I have a folder I've made called files, and then clean PC, whatever the name of your PPKG is. Just copy that there. And then the target is the location I want to copy this file to. And I've created this as an update action. Now, my scheduled task, I've created a create action for the scheduled task. So it's going to create a scheduled task on the device. And if we drill into this, we'll see the name of the scheduled task, the authority of how it's going to run, which in this case is system, and then whether or not the user is logged on with the highest privileges. And in the program I'm using, I'm referencing the PowerShell executable that's sitting in C Windows System 32 Windows PowerShell v.1 or v1.0. And then my arguments are -no profile -command. And then I am calling an ampersand with a curly bracket that says install provisioning package -package path, which is the path to the file that I referenced in the copy command that I did earlier. So C Windows temp, and then my provisioning package, force install, quiet install. In terms of conditions, I have this task is scheduled to wake and only run on AC power. And everything else, I believe, is default. And then the last thing you would need to do is take this policy and target it to a OU, and then your devices will be able to execute this provisioning package. So our next demo is applying automatic maintenance without shared PC, leveraging group policy. So this demo is for those of you that cannot use shared PC or do not want to use shared PC because of some of the local policies that we set. So for instance, I made mention earlier that OneDrive file sync is disabled by default in shared PC, and you can override that through group policy or MDM. However, there are a number of other policies that you may not be comfortable with applying through shared PC to the vast majority of your devices. So this essentially will get you to the bare nuts and bolts of exactly how to configure automatic maintenance through group policy, and we essentially leverage a number of group policy objects that configure automatic maintenance, and we also configure the RTC wake timer through PowerShell for the power schemes that are on the device. And then lastly, we talk about how you can configure a scheduled task to wake the device, because we need something that invokes automatic maintenance. Just setting automatic maintenance by itself does not wake a device. That it preps the device to be woken, but something has to wake it up, and that is going to be a scheduled task. So the first thing we need to do is we need to set our maintenance scheduler policies to allow for automatic maintenance. So if you go into group policy, go into computer configuration, policies, admin templates, Windows components, there's a policy to configure called maintenance, or there's a folder in here called maintenance scheduler. Under maintenance scheduler, you will have automatic maintenance activation boundary, random delay, and wake up policy. So at the very least, you need automatic maintenance activation boundary and wake up policy set. Random delay, this is that 2-hour random delay I was mentioning earlier that shared PC sets. It's up to you if you want to set that random delay or not. If you want your devices to all wake up at the exact same time, then do not set the random delay. However, setting a random delay can be helpful because it will prevent resource storms from taking effect in the event that you have thousands of devices all waking up at the same time, all trying to get policy from your SCCM server. So keep that in mind. A random delay is probably a good idea, and I would recommend 2 hours as a good time to set that too. So under activation boundary, we'll need to make sure to enable this. And when you enable this, you need to enable this and then set the activation boundary in the format that you see here. So in this case, we use 2000, 01, 01, T, and then 2300 as the time. So in my environment, 2300 is set for 11 p.m. If you want to do this at midnight, just set this to 00, and then this would be set to midnight. So if you want to do 1 a.m., 2 a.m., then 01, 02, and so forth. Our wake up policy is just an enabled radio button. So this is what will allow for the wake request to wake the device up at scheduled time. And then for our random delay, we can enable this, and then this is in this PT4H format. So this would be 4 hours for my delay. In this case, I can set my random delay to 2 hours, and then my devices will wake up between whatever I set the maintenance activation boundary to plus 2 hours. And then once those policies have been set, your next policy that you'll want to configure will be the Windows Update setting for set edu restart. And the way we actually reference this as update power policy for cart restarts. In MDM, this is referred to as set edu restart. So what this policy does is it allows the device that if a device is in a cart, it'll skip power checks to ensure that update reboots will happen at the scheduled time. This description does not tell the whole story, though, about what this policy really does. This policy also enables a Windows Update scheduled task to get created, and then that scheduled task will be it'll be invoked in order to wake the device. So by setting this policy to enabled, there will be a new scheduled task on the device to wake the device up. Because remember, something has to wake the device. Just setting the automatic maintenance policies will not wake it. So by configuring this policy here, you will get a policy that will wake the device up at the scheduled maintenance time. So once that policy has been enabled, you are then ready to deploy your group policy. Now there's one other thing that you need to do, and that is specify the RTC wake timer on your devices. Now there's a couple of ways to do this. You can do this through powerconfig manually, or you can do this through a PowerShell script to apply it to all of your power schemes. So if we look at So if we look at Notepad, in this Notepad I have powerconfig, set AC value index, and set DC value index on the balanced power scheme. And we're setting that the RTC wake to 1. So if you set both of these through, and it doesn't have to be through PowerShell, you can do it through a batch file or a command script or whatever. But if you set both of these for the balanced scheme, then the RTC wake timer will be configured correctly. However, you may want to do this to all your power schemes because you don't know what your students might be up to. Your students could potentially be messing with the power settings, or maybe even your teachers are messing with the power settings. So you could have some devices that are at high performance, some are set to something else, maybe a custom power scheme, who knows. So in order to set that, you can use PowerShell. So I've got a PowerShell script here that essentially uses powerconfig, and it loops through all of the different power scheme GUIDs to configure the power policies correctly. So between both of these, you have the capability of setting the RTC wake timer. But this is what's going to glue everything together, because we need the wake timer to be enabled in order for this all to work. So now if we go into SCCM to deploy our wake timer script, we can take a look at the package of this, or the properties of this package that I've created. And it's going to be the same content that we saw earlier. So let's just open this up. So we have an enable-wake timers.ps1, and if we edit this in PowerShell.isc, we will see that we're using the same script that was shown earlier. And then inside of this package, I can use this package in a OSD task sequence. I can use it in, I can just deploy this if I wanted to, and just reference the command line. In this example, I do not have a program, so this was really used in OSD. So if I go take a look at my OSD task sequence, I have an enable wake timers, and we're just executing enable-wake timers.ps1. If you go to my blog at richardbalsley.com, I have a post here for configuring Windows 10 devices to wake and update outside of class time. And if you're interested in getting the script, the PowerShell script that I referenced on how to set the RTC wake timers, you can copy that directly from my blog. I've also included a PowerShell script copy as well that creates a scheduled task for you to enable a scheduled task that will wake the device up. So if you don't want to use the set edu restart, and if you want to just use your own scheduled task, feel free to do that. There's a script here that can help you do that as well. This post also goes into basically the same kind of depth that I went to in this video, but in maybe a more structured format. So that concludes this, and I hope that this greatly reduces some of the frustration that your students and teachers and maybe you are having with updating Windows devices in the classroom. Thanks.